So thank you everyone for stopping in for this lightning talk today using Milvus as an RDF graph vector store for AI agents. This presentation is by Jeremy Nelson, a software engineer at Stanford University Libraries. He was on the team that migrated Stanford to Folio and is active developer in Sinopia linked data editor and Blue Core projects. His research interests include applying AI to improving library workflows. Jeremy?
All right, thank you very much. So, what I'll be doing today is just showing you or give a brief overview of what Milvus is and how we're using it as an RDF graph, and also a process of how we're planning to use it in BlueStore. So, what BlueStore is what we call the database component of Blue Core. And Blue Core is a collaboration that really envisions a shared linked data environment to bring BibFrame cataloging to production. And so as we were working on the Blue Core stack, we really wanted to think about ways we could leverage the growth and expansion of generative AI, and in particular, how we can use these technologies to assist catalogers in their linked data workflows. We're developing at Blue Core a RDF vector store, and I'll talk a little bit of what a vector store is, and to store RDF triples for BibFrame work and instances. And in our initial development of the prototype, we've started work on an AI agent for detecting work and instant duplicates using this vector store. So here's a diagram of the Blue Core technology stack. On the left, you see Sinopia and Marva, which are existing linked data editors. We also have a helper application called the Graph Toolbox. And you can also use Blue Core if you're familiar with Jupyter Notebooks. So all of these different sort of user-facing applications use an authentication technology called Keycloak. And through Keycloak, then these applications can use the Blue Core API. And the API itself will leverage and use LLMs or large language model AI agents, along with a workflow engine called Airflow to manage more long-standing jobs. And then sort of in the back end, we have a Postgres database that actually stores the works and instances and other resources. And then what the focus on this lightning talk is actually a triples vector store. So when we talk about this vector store, it's really, I like to think of it as a naive graph knowledge base. So each BibFrame working instance has one or more versions that are stored in the Blue Core database. And then in those versions, we take a serialized N triples version as a list of RDF triples. And each one of these triples we store as a separate semantic document in the vector store. So what that means is that we then take each one of the triples and then create or transform it into a embedding. And here is a partial display of that vector, and it's just a large list of floats or numbers. And then as part of that, we store with each vector some metadata. So we store the text of the triple, the URI of the resource, and then the version ID into Milvus along with those vector documents. So once we have those as vectors, then we can do a vector search to match these incoming triples, or as a part of a Retrieval-Augmented Generation or RAG workflow for LLM, a large language model-based agents like the duplication agent that we're working on. And these agents use both LLMs, system prompts, and external tools to sort of construct a workflow. And it also includes feedback from the cataloger who's working on it. The duplication agent and also will include prompts for weighting certain triples, like a main title and contributors as part of that prompt to increase the weighting when it does a match based on the Milvus vector search. Now, this AI duplication agent takes this incoming RDF resource, serializes it to in triples, and then creates the triples embedding. Then it queries Milvus to find the best matches for the incoming RDF vectors. It will then evaluate the results and return scores for best matching works and instances. Our intention is that it can be run within the Blue Core editors, and that's looking towards more of the MVP than the current prototype. And then we hope to have it implemented at least in a demonstratable view in the Graph Toolbox. The AI duplication agent can also be run when they're doing batch loads within the Blue Core workflows DAGs, or directed acyclic graph, which is just a fancy name for a particular workflow in Airflow. Sort of looking towards the MVP to help you be able to enable these agents to be able to use Blue Core and the Milvus Vectorstore. We'll be looking at a technology called Model Context Protocol, or MCP, which is just a standard way for defining an interface between standard systems and large language models. The Blue Core AI agent, so we will use the API as an MCP server for searching, editing, and initiating workflows. And then with the API as an MCP server, you'll also be able to use the Blue Core API with LLMs like Claude Desktop, which is sort of exciting that you won't be just restricted to the existing editors or the Graph Toolbox. So here's some links to everything I've mentioned before. And what I thought I would do is kind of show you a quick demo for the last couple of minutes of what this may look like. So this is a Jupyter notebook. And after importing some necessary packages, I create a Milvus client, and then I use a constrained bound description from the Library of Congress to start to ingest into the data store. So the first thing, we're just grabbing that CBD file, creating a graph and parsing it, and here you can see what this CBD graph looks like. We have an instance, and then we have another instance, and in this case, we also have the BIBFRAME work. So that is then, I read that file in, and then I posted it to a locally running version of the API that ingests it into the Blue Core database. Oh, excuse me. Then we're querying for that version. And so I can run that again. And this version is just a particular point in time for this work. And then finally, I call this function that we have in our Blue Core models that ingests that version into Milvus. So now that's there, I created a quick example graph where you can see here, just using the RDF lib, we create the URI, we add a type of work, and then we create a title, and using part of the title description from our example. So when I serialize that graph, you can see here it's a very simple, not very many triples, like maybe 4, where we have our example work that we define it as a work, and then the BF title. And then as a blank node, we have the BF title, and then the main title that we've set up here. Then we take those triple, or this graph, and then we serialize it as n triples, and then we strip off the ending period. And so here we can see is a list of those triples, and there's the blank node with the title. Here's the actual RDF statement of what type of class it is, and then the main title that links that instance, and then the actual text itself. So then we then take those triples and we encode each one of those lines as example vectors. And then to show you, I can quickly do this. And I'll just show you the first vector. And there you can see it's a really long list, 768 floats. And then we query our search database. So I include what collection name it is, and then the output. And then we can see here we have the matches, and we matched both on the work and the title. And so from these, this would then be passed on to the LLM, which then can make a determination of whether this incoming resource is a match or not. So I think I'm out of time. So Matthew, okay.
Yep, you were right at time, but there's no one after you. So if
Okay.
you want to have anything to close up, you're more than welcome to do that.
Okay. So Milvus comes, I'm just using the default vector model. And those vectors are using, here, let me show you this. All right, so this default embedding function, let's see if we can get more details about this. And so the default is this paraphrase Albert Onyx, but you can also specify different models to use. And so it's a BERT model or a variant BERT model that's generating the vectors. And we haven't right now tried different models, but certainly that's easily enough to do with Milvus. So those vectors, I guess, so how the vectors are determined by Milvus? Well, I don't think I have time to really go through how the full details of how the vector is generated, but it uses that model to tokenize each character and to determine where that exists in a multidimensional space. And then it combines all those different floats that you saw, those float values, to determine sort of its location in the semantic space. As you generate these vectors and store them, then the database itself, when you run different searches, it finds and there's different ways, different algorithms you can use to determine sort of the distance between your example vector and the existing vectors to find a sort of a semantic similarity between those. Yes, the Milvus is an open source vector database. So, and it's actually used quite a bit in other industries that are also looking at using LLMs and RAG in their workflows.
And we do still have time for questions if anyone else has any questions for Jeremy.
Thank you all, and I hope in a future, maybe next year's LD4P, our LD4 conference, we'll maybe do an update on this to show you actually working agents and with Blue Core. So thank you very much, everyone.
Very exciting. I look forward already to next year, and we're not even done with this year. Wonderful. Thank you so much, Jeremy, and for everyone else who presented today.